Have you ever looked at one of those massive container ships just piled high with cargo and wondered how on earth does that thing not just tip right over? I mean, it really looks like it's defying physics, but it's all about a very precise and very high stakes balancing act.
Okay, so picture this. You're the one in charge. Every single container, every drop of fuel, even the water sloshing around in the ballast tanks deep in the hull, it's all part of this giant moving puzzle. And if you get one piece wrong, well, the whole thing could come crashing down.
And if you get it wrong, the consequences are catastrophic. We're not just talking about a math problem here. This is about the safety of the crew, the ship itself, and millions of dollars in cargo. The stakes, they are as high as they possibly get.
So how do they do it? How do they solve this massive moving puzzle? Well, it all starts with one core concept from physics, the center of gravity. This right here is the secret to a ship's stability. So let's break it down. Every single object has a center of gravity, or CG for short. Here's an easy way to think about it. If you could somehow balance that entire ship on the tip of your finger, that exact balance point would be its center of gravity. It's the single point where all of its weight is concentrated, pulling it straight down towards the center of the Earth. Now this slide makes it look pretty simple, right? For a basic shape, the center of gravity is just its geometric center, the spot where it would perfectly balance. A ship, of course, is a much more complex shape, and that's where the real challenge begins.
So you find the center of gravity, and you're good to go, right? Nope, not even close. On a ship, that balance point is a constantly moving target.
You almost have to think of the ship as a living, breathing thing, as giant cranes load and unload containers, as the engines burn through fuel on a long voyage, as ballast water is pumped in or out. The entire weight distribution is constantly in flux. That center of gravity is always on the move, and the ship's officers have to track it relentlessly.
And there are two really simple rules to this whole game. You add weight, and the center of gravity moves towards that weight. You take weight away, and the center of gravity moves away from where that atom used to be. It's this constant push and pull.
So how do you track this constant shift? Well, the old school way involves a formula that looks like this for every single item you move. It looks complicated, and trust me, it is. And that's just for one single item. Now just try to imagine doing that calculation for hundreds of containers, for multiple fuel tanks, for all the different ballast tanks. It becomes a mathematical nightmare pretty fast, and a single mistake could be disastrous. There has to be a better, safer way.
And there is. This is where maritime professionals developed a much more elegant solution. It's called the accountant's method, and it honestly changes everything.
The secret is to stop thinking like a physicist with all those complex formulas, and instead start thinking like an accountant. They basically treat the ship like a giant ledger, with debits and credits for every single item that gets added or removed. It's a simple but really powerful shift in perspective. The key to this whole method is a concept called a moment. It's just a way of measuring the turning force, or leverage, that an object has. The heavier an object is, and the higher up it is on the ship, the more turning force it has. So, you just multiply its weight by its height above the keel, the bottom of the ship, and you've got its moment. So let's actually see this in action. We're going to walk through a real-world example of how a ship's officer uses this exact method to calculate the final center of gravity before a voyage. Okay, here's our ledger. We start with the ship's initial weight and moment. Then we load 500 tons of steel. That's a credit, so we add it to our weight and moment columns. Next, 200 tons of containers go on deck. Another credit. Finally, we pump out 100 tons of ballast water. That's a debit, so we subtract it. At the end, you just tally up the columns to get your final totals. Easy.
And now for the final golden rule. To find the ship's new center of gravity, its final kg, we just take our total final moments and divide by the total final weight. That's it. It's that simple. And there it is, 4.946 meters. That is our ship's new center of gravity. A single, precise number that tells us exactly where the ship's balance point is now located. But here's the million-dollar question. Is it a safe number?
You see, knowing the center of gravity is absolutely crucial, but it's not the whole story. There is one final check that has to be done to make sure the ship is truly stable and safe for the open sea. It's a three-step process. First, they look up a number in the ship's official data book that basically represents its natural built-in stability. Then, they compare that to the center of gravity we just calculated.
If the ship's natural stability is greater than the downward pull of the center of gravity, you get a positive result. And a positive result is exactly what you want to see. It means the ship is stable, it's safe. If a wave pushes it over, it has the power to push itself back upright.
And that, right there, is the hidden math that keeps our world moving. This isn't just a textbook exercise, it is the most critical safety check that happens on every single ship, every single day, in every port around the world. It's a beautiful blend of physics and pure practicality, all to make sure these giants of the sea complete their journeys safely.